Hey guys, welcome to Crown Smart. In today's video we want to differentiate cos x. Now to start this we have to define what f prime of x will be. Okay, using our definition, our f prime of x is the limit as change in x approaches 0 of f of x plus change in x minus f of x all over change in x. Okay, this is our definition of differentiation. That's the first principle. Now we want to differentiate cos x. Now we know our f of x is already cos x. Okay, so our f of x plus change in x, what we do is simply replace x here with x plus change in x. So indirectly we are saying whenever you're having indirectly what we are saying is when you have cos x, you write cos x plus change in x. Anywhere you see x, put what? X plus change in x. So this will be cos x plus change in x. Okay, now recall that our cos a plus b is equal to cos a cos b minus sin a sin b. This is one of the trig identity. So therefore our f of x plus change in x is equal to, remember it is cos x plus change in x, so using the same idea we have this as cos x cos change in x minus sin x sin change in x. Okay, so we have that our f prime of x is equal to the limit as change in x approaches what? 0. What is our f of x plus change in x? Is this actually. So we write it out. Cos x cos change in x minus sin x sin change in x. Now this is for f of x plus change in x. Now minus, what is our f of x? Cos x all over what? Change in x. Okay, so what we do now is we simplify. Okay, this is equal to the limit as change in x approaches 0. Now we have this as cos x cos change in x minus cos x. I simply brought this to this side. Okay, I'm just rearranging it now. Minus sin x sin change in x all over change in x. Okay, so this is actually equal to the limit as change in x approaches 0. We have this as cos x cos change in x minus cos x all over change in x. Okay, minus sin x sin change in x all over what? Change in x. Okay, I just brought this one out here, all over change in x minus this all over what? Change in x. Okay, it's just a similar thing. Whenever you have something like this, let's say you have a plus b all over c, it's saying a over c plus b over c. It's just a simple arithmetic that we normally do. So what happens here is that, recall that whenever you have limit of a plus b, okay, this is the same thing as saying the limit of a plus the limit of what? B. Okay, that's one of our limit rule. So we apply the same thing here. This becomes the limit as change in x approaches 0. This will be cos x. Let me factorize cos x. Okay, so this will be cos change in x minus 1 all over what? Change in x. Okay, this will be minus the limit as what? Change in x approaches 0. We have this as what? Sin x sine change in x all over what? Change in x. Okay, we're not done yet. So what we do next here is this equal to, remember this limit is with respect to what? Change in x. Okay, so we are finding the limit of this function where change in x approaches 0, and here we only have cos x, so we remove cos x out, cos x, and this will now be limit as what? Change in x approaches 0 of cos change in x minus 1 all over what? Change in x. Okay, minus, here happens, here is just the same thing, we have sine x. Okay, and this is the limit where change in x approaches 0, so it's going to affect these ones, so we are going to remove sine x out. So this will be the limit as change in x approaches 0, we have sine change in x all over what? Change in x. Okay, now recall that what we have here now, these are special limits. Okay, this has their own proofs. They have a proof to prove this special limit, and now the limit of this function is 0, while the limit of this function too is 1. The limit as sine change in x over change in x is 1. Okay, and the limit of cos change in x minus 1 all over change in x is 0. This has a proof, and we are not going to do that in this video. Okay, so just take note that this will give us 0 and this will give us 1. So this will now be cos x times, okay, 0, because we know that the limit of this function will be 0, minus sine x, okay, times the limit of sine changing x over changing x will give us 1, so we put this as 1. Now this is equal to, 0 times anything will be 0, so this will be 0 minus sine x. Sine x times 1 will be sine x. So our final answer is 0 minus sine x is minus sine x. Therefore our f prime of x is what? Minus sine x. So if we differentiate a cos x, we have minus sine x, and also if we differentiate sine x, we have cos x. I did that in the other video. Please do not forget to subscribe. I would really appreciate if you subscribe, please. By subscribing, it makes us upload more videos, and I wish you enjoyed this video. Thank you very much.